Hi, this is Maggie. In this video we'll talk about writing mathematical expressions in Python. There is generally a lot of math in programming as computers are fast and accurate at performing calculations. Let's look at some of the Python mathematical operators. This table from python.org shows the mathematical operators. There are many here that we won't cover, but we will look at the operators used for operations you are familiar with from arithmetic. Here you see a plus sign and a minus sign used for addition and subtraction. Here is an asterisk, which is the only way you can communicate multiplication to Python. And then three division operators: division, flooring division, and modulo. We will talk about the differences among those. The two asterisks, together with no space between, are used for exponentiation in Python. And finally, parentheses are used to group an expression. We use only the curved parentheses and not any other grouping operator, so we nest parentheses if we want to group an expression within an expression. Let's write a program that performs some calculations using these operators. One program that's kind of fun and silly, but we can write to use a little bit of math, is one of those magic tricks that asks the user to think of a number, performs some arithmetic on the number, and then tells the user the result they got. Play along with a magic trick with me. To start, think of a number between 1 and 100. Now, multiply your number by 3. Now add 15. Now multiply that by 2. Now add 12. Divide by 6. Now subtract your original number. Ready for the magic? You got 7. Feels magical? It's the magic of algebra. We can write a program that performs one of these tricks along with the user, which is less magical, but allows us to practice some math. I've already written the program to save time. Let's run the program first, then look at the math. The program begins by asking me to enter a number between 1 and 100. I'll just give a small number, so it's easy for us to do the computations in our head. So I'll type 5. Now the program tells me to multiply it by 3 and press enter, so I get 15, and I'll press enter and it tells me 15. Now I'm instructed to add 15, I get 30, press enter, and the program confirms the result. Now I'm instructed to multiply by 2. I get 60. Press enter, and that is confirmed. Now add 12. I get 72. Press enter, and that result is confirmed. Divide by 6. I get 12. Press enter, and that is confirmed. But notice that instead of showing me an integer 12, the program shows me a float, 12.0. We'll look at the program in a moment and see why it suddenly has a float in its calculations. Let's finish up. I'm supposed to subtract my original number, which was 5. So I get 7 when I do that, and the program confirms I get 7. This is not very magical because the program knows the user's number and is performing the math along with the user, but that's because we want to look at some math in Python. Let's look at the program. I have used two variables in this program, num for the user's original number, and nextnum, which is the value after each mathematical calculation. I need to keep the original number separate from the intermediate calculations because I have to subtract it in the last step, but I don't need to keep any of the intermediate values, so I write over nextnum each time with the newest result. We begin by obtaining the number from the user in an input statement and casting it to an integer. The next calculation is a multiplication. And you can see I have multiplied num by 3 using the asterisk operator. That is the only way to multiply in Python. I also have another multiplication, a couple of additions, and a subtraction at the end. Remember that after our division here, next num equals next num divided by 6, we got a floating point result. Division in Python using the division operator will always yield a floating point result. If we want an integer result, we should use flooring division, which is 2 forward slashes with no space between. Let me change this to a flooring division and run the program again. We'll zip through the steps until we get to the division. Okay, here's the division. Notice that this time I got 12 and not 12.0. So that's fine because there is no fractional part in this division and there won't be, but what if there is? I'm going to experiment in the console a little bit and show you. Let's type 72 divided by 6 in the console, and we can see the result is 12.0. Now if I type 72 / 6 or flooring division 6, I get 12. But what about something that doesn't divide evenly? I'll try 72 divided by 5 and I get 14.4. But 72 flooring division 5 and I get 14. What is happening is that flooring division is giving me the number of whole 5s I can get out of 72. That number isn't rounded, it's floored, which means brought to the nearest whole number below or less than the floating point result. Practice with it yourself in the console until you can consistently predict the correct result. Now there is one other important division operator, and that is mod. Mod gives us the remainder of an integer division. So if we're wondering what was left over from that 72 after taking out as many 5s as we can, mod will give us the answer. We write mod with a % sign. It does not compute a percent. It computes the remainder of an integer division. I write this as 72 mod 5, and the result is 2. That means there is 2 left in the 72 after I take out 14 5s. This is another operator you should practice with until you can consistently predict the correct result. We also saw an exponentiation operator on the python.org site, which is 2 asterisks with no space between. So if I type 2 asterisk asterisk 5, Python will tell me 32, which is 2 to the 5th power. That's a very handy operator, and not all programming languages have an exponentiation operator. The table on the Python.org site, let's look at it again, is showing us operator precedence. In this table, the lowest precedence operators are at the top. Therefore, we can see that the PEMDAS operator precedence you likely learned in school is preserved here. Parentheses have the highest precedence, and then exponentiation, and then multiplication and division have the same level of precedence, and then addition and subtraction have the same level of precedence. Add flooring division and modulo to the multiplication and division level. And remember that operators with the same level of precedence are calculated left to right in an expression. Let's look at one expression and talk about the order in which it is computed. Here we have 1024 divided by, open paren, 12 minus 10, close paren, raised to the third power, times 2. The highest precedence here is the parentheses. So what is inside the parentheses, which is a subtraction, is computed first. That leaves us with 1024 divided by 2 raised to the third power times 2. The operator with the highest precedence now is the exponentiation. So we compute 2 cubed and get 8. Now we have 1024 divided by 8 multiplied by 2. We now have two operators, division and multiplication, and they have the same level of precedence. We compute them left to right in the expression. So 1024 divided by 8 is 128, and that is a floating point result because this is a division. And then finally multiplied by 2, so 256.0 is the result of this expression. If we type it out in the console, we'll see that's the result that Python gives us. As with the other topics in this video, I recommend you predict the order of operations in a number of expressions and confirm with Python until you predict with perfect accuracy. When in doubt when writing an expression, you can always enclose expressions in parentheses to force the order of operations. But it is important you understand the built-in order of operations when reading other programmers' code. When we are converting a mathematical expression to Python, we are restricted to what we can write on a single line using a standard keyboard. This means we can't write some of the symbols that we're used to writing in word processors that have equation editors. We can't write anything that uses numbers in superscript or subscript locations like radicals, integrals, division bars, and exponents in their traditional forms. You might have noticed that the python.org order of ops table, that there are many symbols from mathematics that we simply don't have in Python. To substitute for that, we have function calls. Some math functions are built into Python, and some are located in the math library, which we must import. You can visit python.org to look at the documentation for all of the functions that are available in the math library. We'll look at a couple of them here and talk about how to accurately translate mathematical expressions to Python. Some math that is loosely related to an aerial fireworks program is the computations involved in projectile motion. I'm going to use some equations related to a non-exploding projectile because they will better illustrate how to convert an equation to Python code. The three equations I think are interesting are the time of flight, which is 2v0 sine theta over g, the maximum height, which is v0 squared sine squared theta over 2g, and the horizontal range, which is v0 squared sine 2 theta over g. You can see how these equations look when written in an equation editor. The typical way of writing these is to append or run together quantities that must be multiplied and to use a division bar. We also have the trigonometric function sine in these equations. To convert these to Python, we'll embed them in a program that gets the initial velocity, v sub 0, from the user, as well as the angle theta. We will assume the initial velocity is in meters per second, and gravity is the gravity on Earth, 9.8 meters per second squared. We have a constant here in our program shell defined up in the variable annotations. Now to convert the first expression, time of flight, we will start with an assignment statement on the left, time equals. Now the part on the right is the interesting part. First, we have a division bar with a numerator piece and a denominator piece. A division bar is essentially a grouping operator. It's just written differently from parentheses, but you will always compute the numerator and compute the denominator before computing the division. So to write this out in a straight line, we will enclose the numerator and the denominator in parentheses. Here the denominator is just one thing, g, or acceleration due to gravity, but we'll enclose it in parentheses to reinforce that this is what we must do with a division bar. Now, in the numerator, we have 2 v sub 0, or 2 times the initial velocity. So we must put an asterisk between those to communicate multiplication to Python. And then we also need to multiply that by sine theta. But how do we compute sine theta? Sine is one of the math functions available in the math library, but the sine function does not take degrees as an argument. It takes radians. So we will have to convert theta to radians. To use these functions, we will import math at the top of our program, under the docstring at the top, and we will do it this way. We will write from math import sine, comma, radians, because we are only going to use those 2 functions from the math library. When we import this way, we do not need to prepend with our library name. To convert the radians, I'll reuse the same variable and write theta equals radians, open paren, theta, close paren. Down in my computation, after the asterisk, I will write sine, and then within parentheses, I put the argument, which is theta, now converted to radians. I will put gravity in my denominator. That computes my time. Now I'll also compute the height for one more example, but I'll leave computing the distance to you as an exercise. So height equals, and now this time I again have a division bar, so I'll put parentheses, division sign, parentheses. In the denominator we have 2g, so I'll write 2 times gravity here. The numerator is almost exactly like our prior numerator, except we are squaring both the initial velocity and sine theta. I will use the exponentiation operator to write init velocity raised to the second power times sine theta raised to the second power. Now let me pause the video and write some output statements, and then we can run the program. Okay, so here are my output statements for time and height, and let me run the program. I'll give an initial angle of 50 degrees and an initial velocity of 20 meters per second, and the program tells me that the time of flight or time until it reaches the initial height, again, is 3.126 seconds. The program tells me that the maximum height is almost 12 meters, 11.976 meters. So those two rules you really need to pay attention to are to always use a multiplication operator to communicate multiplication, and always group with parentheses when there is an implicit grouping operator like the division bar. I recommend you practice by writing out the final equation for distance. For an initial velocity of 20 meters per second and an initial angle of 50 degrees, you should get a horizontal distance or range of 40.196 meters. You should also practice with order of operations by writing out expressions with multiple operators in different orders, predicting the results and confirming your prediction in Python. You should practice with the mod operator, division, and flooring division. And you should read through the python.org math library page to see all of the mathematical functions that are available. There's a lot more than sine. Final thing you might try is converting equations that are interesting to you, and testing that you've written your code correctly by running test cases with known results.